10Cs, welcome to day 2 of trigonometry. Before we get started with the lesson, real quick, because there is some key stuff that we talked about in the last lesson. First of all, trigonometry this year is all about right angle triangles. Has to be a right angle triangle of some kind. Doesn't necessarily mean it has to be sketched exactly that way. The right angle can be anywhere as long as it's a right angle triangle. So in the past, we discussed the 180-degree rule for finding angle sizes. If you know two angles, the third angle has to total 180 with the other two. We also talked about the fact that Pythagorean or Pythagoras' theorem is a process to find an unknown side length when you have two other sides. And we reviewed that from previous. Well, after that, we started to look at the fact that angles and sides work together. And angles and sides work together in trigonometry. But there are a couple of key things. The first point is you always need to identify a reference angle. Remember, you have two angles to choose from because you never choose the 90-degree angle as your reference angle. And the reason the reference angle is so important is because we have to label our sides hypotenuse, side opposite, and side adjacent. And that can only be done once you know which angle you're working with. And the reason that the hypotenuse, opposite, and adjacent are so important is because we then have the three trig ratios: sine, cosine, and tangent. SOHCAHTOA. Because the sine of some angle always compares the opposite side to the hypotenuse. Sine is opposite over hypotenuse. The cosine of a given angle is always the side adjacent over hypotenuse. Cosine adjacent over hypotenuse. And we finish with the tangent of some angle is always the side opposite over the side adjacent. Tangent is opposite divided by adjacent. So choosing an angle to work with, labeling the sides appropriately so you can choose the correct trig ratio is essential. And the last little bit here, you have to make sure your calculator is always in degree mode. That means a couple of different things. If you have the graphing calculator like you have been asked to have for this, it's possible that you will be in a mode that seems to make sense, but if you're not in the correct mode, it's not going to work. So we need to make sure that you are always working in degree mode. You can check to see if you're in degree mode. Let me just bring the calculator into the screen here. Is on your calculator, you hit the mode up one of the top buttons. You want to make sure and scroll down so that degree is highlighted and not radians. If radians were highlighted, now we can see that radian, fourth line down, is highlighted. It's going to give you an answer, but not the answer we're looking for. We want to make sure we highlight degree. Hit enter. And now we're in, and clear it. Now we're in degree mode. On my, you can see up at the top, it says degree, so we're good. So that's what you have to make sure of. Now, some of you might not have the graphing calculator. Well, at the top of your calculator's display where the numbers are, you got 0 and you might have a 3 or whatever. So it's a backwards 3, but you need to make sure you have DEG or you have a D showing. It could also possibly say rad or grad, or it could have an R or a G. You need to find the little button on your calculator that has a DRG, and you need to hit that until you get degree or D on your display. Then it'll work. So, with that being said, make sure you're in degree mode. And let's take a look. Calculating side lengths in a right triangle. Big difference We did possibly have the ability to use Pythagoras in the past because Pythagoras will find side lengths, but what we see here is we only have one side given. I can't use Pythagoras with only one side, but we can now, with trig, start to use a side and an angle together. So here's the process we're looking at. Same steps over and over. What's frustrating about this unit is it's the same steps over and over. You get bored of hearing me say the same thing. What's nice about this unit is it's the same steps over and over. If you know the steps, it's a repetitious process. So here we go. We're trying to find a side length. Our first step is to identify a reference angle. Well, never use the 90 degree as your reference angle, so we have two choices. In this case, what are we going to use for the reference angle? Well, the reference angle should be the angle you have. The angle that we know is going to be our reference angle. Why? Because I need to use what I know to find what I don't know. So, choose an angle, we're going to use the reference angle. Second step, label the sides, which we practiced in lesson 1. So, opposite the 90 is the hypotenuse. Opposite across from the reference angle is the opposite side. And that leaves the adjacent side, which is adjacent to the reference angle but isn't your hypotenuse. So, we know we're using angle 53. We know the names of the three sides. Now we choose the trig ratio. Do we want sine, cosine, or tangent? Well, talked about this in lesson 1. Look at what you're trying to find. We're trying to find this side here. So that's an important side. We need to work with the opposite. The adjacent. The adjacent's given to us. I need to use what I know to find what I don't know. The hypotenuse, we don't know it. We're not trying to find it. In this case, the hypotenuse isn't useful to us. So we need the trig ratio that's using the opposite and the adjacent side. Opposite hypotenuse, adjacent hypotenuse, opposite adjacent. In this question, we want the tangent ratio because the hypotenuse does not do anything for us. So now what we're going to do is we're going to substitute the values into the tangent ratio we talked about in lesson 1. What was the tangent ratio? Tan. Always put in your reference angle now. Tangent, we're using 53 degrees, and remember it's opposite over adjacent. Opposite is unknown over the adjacent side length of 3. There's our values. We chose the trig ratio. We wrote the trig ratio, making sure to include the reference angle. And now we solve. Now, solving for a side length is cross multiplication. We don't have a proportion quite yet, but I can take my tan 53, set it over 1, and now I can cross multiply. Couple things with cross multiplying. As a review, we're going to multiply the two pieces of information we know for sure. We have tan 53 and we have 3. And we always finish by dividing by the extra piece because this is what we're trying to find. Cross multiply what you know, divide by the third piece to find that last piece. So when I do the calculation, I'm going to multiply tan of 53, not just 53, but I need all tan of 53 times 3, and now I divide by 1, and that will give me my x. Cross multiply tan 53 times 3, divide by your extra piece, and that equals what you're trying to find. There's what the calculation needs to look like. So now on our calculator, here we go. We're in degree mode. We want to do just what it said, tan 53 degrees. Make sure you put that in brackets. Tan 53 has to be 53 in brackets because now I want to multiply by 3 and divide by 1. Tan 53 times 3 divided by 1, and there we go. 3.98. There's our side length. Now, side lengths usually go to the tenths place, so 3.98, x is 3.98, blah, blah, blah. Round to the tenths place, 8 rounds it up, and the 9 rounds up, and we end up with 4. So we have a side length here of 4 units. We've solved for the unknown. There's the process. Now, just going back really quickly, you'll see if I did tan 53 times 3 and don't put the brackets and divide by 1, well, this is telling me that we want, that's saying that this 53 times 3 divided by 1, all of that is going to be tanned. We just want 53 to be tanned. So it's essential because if I hit enter there, not even close to the same. Make sure your degree is put in brackets. There's your steps. Not overly complicated. Not a lot new today because everything, like I stressed in lesson 1, it's setting this up. We practiced the reference angle and labeling and choosing the trig ratio in lesson 1. That's what this is all about. Here we go. Next one. Page 11, keeping going. Let's walk through this one. First thing, identify the reference angle. Well, trying to find side x, reference angle is the angle we know, which is 26. So there's the reference angle. Label our sides. Opposite the 90 is hypotenuse. Opposite the reference angle is side opposite, and that leaves adjacent. So from there, what are we going to do? Here we go. We want to find the adjacent using the opposite. Those are my two sides because that's what I want. That's what I know. Again, the hypotenuse isn't helpful. So when we choose our trig ratio, hypotenuse isn't given, so those are no use. Opposite adjacent, we're using tangent again. Tangent of our reference angle, which is 26 degrees, is opposite, which is 10, over adjacent, which is x. TOA, tan, is opposite over adjacent. Substituted the values in, along with the first 3 steps, and now we solve by cross multiplying. Well, be careful. This cross multiplying is a little bit different this time. What can we multiply this time? 1 times 10. Sorry, I don't want an X. I want a bracket there. We have 1 times 10, and now we want to divide by that extra piece. 1 times 10 divided by tan 26 degrees will equal what we're trying to find. Some people might want to write this 1 times 10 divided by tan 26 degrees. It's up to you, but that's the calculation we need to do. So on our calculator, whoops, wrong sheet. On our calculator, tan is not what we want to start with. We want 1 times 10, correct? Double check, I've forgotten already. 1 times 10 divided by tan 26, 1 times 10. Now, sometimes I like to hit enter before tanning. It's just my hang up. 1 times 10 is our first calculation, and now we're dividing tangent of 26. Hit enter, and we get 20.5 for a side length. X is 20.5. So there we go. 20.5 for our X. Now I do notice, now that I'm looking at my notes, a little bit different than what you have in the booklet. I see that your 10 is actually up here. That's okay. If you want to solve yours, we're going to do more examples. I wouldn't worry about it, but X should be 9. But for the calculation we did, X here is 20.5. So let's try a couple more. Apologize for that mix-up, but still, it is what it is. Page 11, I've set it up correctly. Let's do the last one on 11. My suggestion, pause the video, give it a try, see what you come up with. So here we go. Identify the reference angle. Well, trying to find X, use the angle that you know. Label your sides. Opposite the 90 is the hypotenuse. Opposite your reference angle is opposite, and that leaves adjacent. So what's useful to us? Opposite is useful. Hypotenuse is useful because this is what we want to find. This is what we know. The adjacent doesn't do anything for us. So adjacent isn't going to be helpful. So that's going to leave us opposite and hypotenuse. This time, we're using the sine function. Sine ratio, sine of our reference angle equals opposite x over hypotenuse 24. Because sine is opposite over hypotenuse. Last step, nothing changes. That's what's great about this. This here, choosing your trig ratio, if you set up correctly, this is the most thinking you have to do. Sine 32, cross multiply. What can we multiply in this case? Here's where our cross multiplying occurs. Sine 32 times 24, divide by that last piece, that gives us x. So that's what we need to calculate. Sine 32 times 24 divided by 1. So we have sine 32, close your bracket, times 24. Again, sometimes I like to hit enter. It's just my hang up. And now I divide by 1, which really doesn't do anything. So we get a length of 12.7 when rounded. X is equal to 12.7. So there's our side length, 12.7. Shorter than the hypotenuse, which it should be, so it makes sense. 2 more very quickly. Pause the video, give it a try, and I'll walk through them very quickly. This is page 12, number 5 and 6. Give them a try. All right, here we go. So what we are looking at now, choose your reference angle. Trying to find x, so I'm going to use 42. Across from the 42, opposite the reference angle is opposite. Opposite the 90 is hypotenuse. Adjacent, we don't need it. We're not trying to find it. It doesn't have anything. So, ka, koa, there's your choices. Hypotenuse, opposite, we're using sine. Sine of the reference angle, make sure you include that. Opposite, x, over hypotenuse, 13. And now we cross multiply. Sine 42 times 13, divide by 1, should give us our x. Sine 42 times 13, divided by 1, x should work out to be 8.7. And the next one, again, trying to find x. The reference angle will be 70 because we know it. So opposite the 90 is the hypotenuse. Opposite the reference angle is opposite. This time we're trying to find the adjacent. So we're trying to find the adjacent. We know the opposite. Hypotenuse doesn't do anything for us. Adjacent and opposite, there's tangent. Tangent, opposite and adjacent. So tangent of 70, opposite 12 over adjacent, which is unknown. And at that point, set it over 1 and cross multiply. Here, 1 times 12, divide by tan 70 to equal our x value. So 1 times 12 is 12, divided by tan 70, x works out to be 4 and 4/10 for a side length. There's the process for finding angles, or sorry, finding side lengths. So here we go. Word problems. Now, finding unknowns in a word problem. No diagrams given. Sometimes you have to do that thinking yourself. The key for all of these word problems is you need to sketch what's happening in the question. And within that sketch, you need to have a right triangle of some kind. So draw careful. You have a guy wire that's 11 meters long attached to the top of a flagpole and to the ground. So you have a flagpole with a flag on it, possibly a guy wire. That's just a wire that you see attached to a tall object and then attached to the ground for security. So it says that it's an 11-meter long wire. It's at the top of the flagpole and it's attached to the ground somewhere. Well, just with that information, hopefully you see that you have a right angle triangle. The flagpole is stuck in the ground at 90 degrees. Are all things stuck 90 degrees into the ground? Not necessarily, but I could make a question that gets ugly like that. Keep it simple with these. Now here's where the biggest mistakes can occur. The wire makes a 40-degree angle with the ground. This is frustrating. Here's your wire. Here's the ground. The wire and the ground, there's your 40 degrees. Putting 40 degrees up in here, that's just not thinking. You have to read with word problems and put some thought into it. So make sure, please, that you are writing the proper angle in the proper spot. So with that being said, there you go. What are we trying to find? We're trying to find how tall the flagpole is. Do we have a right angle triangle? Yes. Do we have all the information we need? I think so. Here's what we're trying to find. So, reference angle. Boom, 40 degrees. Once you have your reference angle, now I can label my sides. Across, opposite the reference angle is side opposite. Across, opposite from the 90 degree is the hypotenuse. That leaves the adjacent. Trying to find the opposite. Using the hypotenuse because that's what we know. So, ka, toa. What uses opposite and hypotenuse? Right there, sine. So there's what we need to use. Sine of our reference angle, which is 40 degrees. Opposite is unknown over the hypotenuse of 11. And how do we find a side length? We cross multiply. Sine 40 times 11 divided by that extra piece will equal our x. Sine 40 times 11 divided by 1, x works out to be 7.1 meters. So it's a 7.1 meter tall flagpole because that's what we were finding. There you go. It's a matter of reading carefully, doing a somewhat accurate sketch. Pause the video, give the last example a try, let's see what you come up with. All right, so ladder is leaning against the wall. Here's our wall. There's a nice, some draperies in the window. Make it a brick wall. There you go. Look at that. Eh? Who says I can't draw? And the ladder is leaning against the wall. So a ladder on a wall, what do we know? We know the ladder meets the wall at 18 degrees. Here's the ladder. Here's the wall. So we know we have 18 degrees there. Well, let's finish the triangle. From the bottom of the building to the bottom of the ladder, there's the third side of our triangle, and the building makes a 90-degree angle with the ground, which makes sense. The ladder meets the wall at 18 degrees, but it goes 5.3 meters up the wall. So I'm just going to erase part of my sketch there, which I did such a nice job of, so I can put my 5.3 meters. That's how far the ladder goes up the wall. You can go 5.3 meters up the wall. So the question is, how long is the ladder? There's the information. Do we have enough? Let's figure it out. We're going to need SOHCAHTOA right away. So start with reference angle. Going to use the 18 degrees because we know it. Opposite, the reference angle is opposite. Opposite the 90 is hypotenuse, and that leaves adjacent. Which side is of no use to us? Well, we're trying to find the hypotenuse. We know the adjacent. Opposite's not doing anything. So the hypotenuse and adjacent, there you go. Adjacent hypotenuse. We don't have opposite, so that's no use to us. So we're doing cosine of our reference angle, 18 degrees, adjacent over hypotenuse. And adjacent over hypotenuse, cosine of 18, adjacent is 5.3 over the hypotenuse, which is what we're trying to find. Find a side length by cross multiplying. 1 times 5.3 divided by that extra piece, which is cosine 18, will equal the x, which is the length of the ladder. 1 times 5.3 divided by cos 18 gives us 5.6 meters. So our x is the 5.6 meter long ladder. That's what we solved for. Finding side lengths of right triangles. Process over and over. It gets repetitious. Hopefully that makes it easy after a first couple. Booklet, page 13. All the questions there. Answers are at the bottom of the page. Check them out. Textbook, page 82 to 83. Textbook is important because here you have some word problem practice. That's always what causes the grief with this. Once you get the hang of solving, it's the word problems that make you frustrated. So practice them. Not too complicated. It's an important process. Lots of little things that you got to think about, but very, very manageable. Have fun.